in a nutshell, this is programming a weld cell. You know, you spend a lot of time in front of the part, you get intimate with it. I've been like crawling up on top of parts, you know, laying there because you want to watch that path. But really what it comes down to is we jog the robot with X, Y, and Z. You know, also these ones over here, they give us some rotations. We can also jog individual joints, but for the most part, you know, we're looking at X, Y, Z coordinates, and we're going to jog that robot into position. We're going to hit insert enter, and we just taught that point. So that point now gets dropped into my job. And then I add, you know, and then I go to the next point, I do the same thing, you know, just drive it down there, insert enter, might have to go around the corner, whatever. And you just kind of watch that torch posture. So, you know, when you need to rotate, then we're on this side. And then I drop in my arc on, arc off commands. So these pens have torque cut keys for arc on, arc off. We will, you know, we'll go in and set up those arc start files, which is what this is right here. I'm just saying arc start file 1, and we'll show that in a minute. This kind of shows it a little bit. So this is from MotoSim. This is my simulated pen, my virtual pendant. This is what the real one looks like. You can see all the buttons are the same. Somebody walked in again. And we've been looking at ways to fix that, and we don't know what the fix is going to be, but hopefully one day we get it addressed. Drop in my arc on, move through my path, arc off, go to the next one. That's it. Flip this key switch to run and hit start. You're welding.
So like the ASF1, that's your like weld profile then?
Yep. And so that looks like this. Something new in the last 3-4 years is universal weld interface. So before we had an interface that would go on the pendant that would be, it was different for any welder. Thanks for coming. Different for any welder that you have. So Miller had their interface, and I mean, they were Motorman built, but, you know,
They didn't all look exactly.
they didn't look the same at all. Yeah, they were all totally different. There were a lot of times where I didn't even use the interface. So the other thing, we can set job mode also. So that arc start file can just call, job mode would be I can set up a job or a profile on the power source itself. So, so now I set up all my weld parameters on the front panel of the Miller or the front panel of the Fronius. And really the Fronius ones, I've ran these like that primarily because they've got a really nice interface panel on them, and it was easy to do, easy to follow into it. And then we would just call our arc start file and say, you know, calls job 1 on the calls job, next arc start file 2 calls job 2. And so we'd have them set up that way. And so I didn't even really go into it because they were hard to navigate. Now I love universal weld interface because they've made it easier. There's some good help sections. All the terminology is exactly what, you know, each manufacturer has their own terminology. And so this kind of shows the same 3 settings in different, you know, and I could have gone through all 5, but really it's, you know, amps, arc adjust, arc control, where these, you know, this would be wire feed speed, arc adjust, arc control. This one's wire feed speed, volts and pinch. And depending on what weld profile you're using, whether it's MIG or AccuPulse or, you know, some sort of a pulse, these can be, you know, these will change and they'll be a little bit different, but it's basically the same terminology that you're gonna look at on the front panel of that welder. And it shows up in here. And so it just, and then, you know, as far as on the pen, it's the same look and feel no matter which power source you have. All of the process functions are going to be set there. So in all those different processes, we set up ahead of time. This is also where we've got, so this is kind of main condition, right? This is main condition, main path of the well. And then there's start condition files that you can use if you need to. There's end condition files that you can use if you need to. And so that would be like crater fill or, a little more voltage at the start, anything like that. That you can easily put in there. And that is my arc start file. So going back up to here, when I did that arc on command and I'm using ASF1, that's going to be an arc start file, and so, or arc start condition. And so that would be ASF. This one here is actually file 3, so that would be I'd call arc start file 3 to use that one. Now, and this, so again, this is the pendant, this is the front pendant. I've got an arc weld button. This is how I get to these. And then there in that selection, there's also like weave files. And then different menu selection for if I was doing Commark or the touch sense. But so all those robot related functions are still done right on the pendant too. So all of those are easy to add in. There's some more. I mentioned that we can put a pendant in your hands, let you drive the robot around and teach some of those points. You can see, I know you've done that already. But if you want to see, kind of what goes into it or how much different it is from like a material handling robot to a welding robot, we got time. We can do that. As far as, so the other thing that a lot of people talk about is offline programming. So, offline programming, we will use offline programming here a lot just for this, validate the process. Does this robot have the reach? Is the tooling going to work out for me? Do I need to reposition my tooling? Do I have torch access to all the points, for that fixture? Because it's one thing just to be able to reach that corner, but I might have to have some articulation when I do, right? So if I'm at the end of my reach and I can't articulate, I need to know that. I'd like to know that before I buy the robot. And so we can help with that. We do a lot of simulations right here. The other thing that can do is it allows us to develop new programs without having. So now I've got a job programmed and my robot's going to town on it, but I've got a new part coming up and I want to get that into the mix, right? So if I'm not doing offline programming, I got to take that robot down for a day, 2 days, a week, whatever, depending on what your weld is like, just to get that part programmed. If the robot's not running on night shift and I got a robot champion that can do that on night shift, that's fine, but there's a lot of times where we'll kind of say you're never going to get 100% of the way on offline programming. You'll get 80 to 90% of the way. And a lot of times, for anything else, it's like it makes it easier, to sit at your computer, with a stack of prints. You can really kind of decipher what the best path is to that. Like, how do I want to sequence these welds? A lot of times I have a part that has 20 welds on it. I might have a part that has 120 welds on it. It's like, how do I sequence that? Where do I start? And so that offline programming to me, it makes it a lot easier just to work through that and see and then you can play around with it and see what might be more efficient. And then optimize existing programs. So I can pull my existing program into here. MotoSim is a simulated controller. So I can pass jobs back and forth between the robot, the real world robot, and MotoSim real easily. And so I can pull the job that I'm running in the MotoSim and I can edit it, check and see if maybe, hey, would changing this path to later in the routine make more sense? Let's find out in MotoSim before because that's the thing that's going to be quicker to do in MotoSim than on the real robot. As far as programming goes, especially using MotoSim, it's not going to be a lot fast. It's it's not gonna be extremely faster than standing in front of it. It makes some of those other things, easier, you know, especially if I want to compare two different routines. There are some shortcuts, there's some handles, that I can click on and be able to snap my TCP down to the part. That's faster than standing there and driving it down there, you know, but other than that, it's like doing that tap and dropping the arc on, arc off in, and, you know, that's not gonna really, it's not gonna be a whole lot faster. So, but there's other packages out there, right? So, there's Delphi, there's Octopus, what else is there? RoboDK doesn't really do weld path that well. Senate. And the ones that we've seen, the ones that I've had exposure to have been Octopus and Delphi. Now they're gonna do a great job. I won't say great. They're a lot more refined than Motorcements. So when I say Motorcements, that's going to be, it's just like running the pendant, right? So, we have some of those shortcuts. Like I said, we can snap to, the part of the model, or, I can snap to, I can type in a position and just have it go there. But for the most part, it's like running that pendant. So and you can see we can drop in models, but it's not as well refined as like SolidWorks, you know, where your Delphi and your Octopus are going to be more like a SolidWorks environment. But what that does is you can set up, ahead of time, you can set up torch angles, flare, in and out of the corners, things like that. And then now you can just pick the joint you want to weld and it builds that path for you. And so, that takes a lot of time out of it. And that's really, I mean, they're developed for creating that program, for creating that job, taking the time out, right? So creating it faster.
There's a huge difference in investment though as well.
Yep, exactly. So this right here, like, so which one do I pick? Well, that's going to depend on what your utilization goal is, how often do I see myself using that, how many times are we going to throw different parts at it, and what my budget is. Because, you know, this is some 10,000, let's say. And if you're buying a weld cell, well, sometimes we can get that discounted, where the other ones are going to be like 30 to 60,000, 80,000. And it kind of, and they have some different tiers, so it kind of depends on which package you get, but there's a huge investment in those ones. Now, they create the path for you, right? They'll build your job. You just export it and put it in your robot. Again, I'll say, you're still going to want to go in and drive to each one of those points and make sure that it's on, you know, and there's a lot of times where you're going to have to doctor them up or dial them in. But so if you kind of think of it as, you know, I can get 90% of the way there and so I clean up some points, that's fine. The one thing that I noticed about them is they work great when that path plans out the way it should. As soon as I need to make an adjustment, it's really easy to throw things way off. Like sometimes, like I got to the point on one where it was easier to just delete that. I had to figure out a way to to pick that line or that joint in a different way. And then because it would, like, you know, when I tried to make adjustments to the path that it created, it wanted to flip my arm upside down. It wanted to rotate, you know, it's like, and it was like just a struggle to get through. Now, if I would have spent more time with it, I might have understood what was going on. It's like, you know, we even had was text support. No, it should just do it. So I deleted it out and I found a better way to pick it and it's fun. So